a mass times a distance. Well, it seems weird, but we're going to need to do that to find the center of mass. Okay, how about,
So, Joanne?
let's keep going and then I'll answer your question, okay? So how would I find, Chris L., how would I find the centroid?
Area.
Sum of the area times
Mass or
the distances
distance.
divided by,
The distance. Oh, wait.
I'm trying to get a distance. You don't even, see, you guys don't even know that you've done this before. You've done it in math, and they had you do all this integration, you had no idea what you were doing. And now we're actually talking about physically what you're really doing. If you want to get distance and you multiply the sum of the areas,
divide by the area.
we gotta divide by the area. Seems weird, huh? Okay, Jill, how about this one? Centroid of volume,
Sum of the volumes times distance.
right?
Divide
Sum
by
of the
sum of the
volumes times the distances over the sum of the volumes. Okay, Hallie.
So, before we were considering that center mass, center of gravity, and centroid were all at the same point, right, for a uniform homogeneous.
And they still will come up to the same point, but in what we're dealing with, that's only if it's a homogeneous body. Think of engineers, what do we design? We don't just design one thing, like just this pen, it has a cap. It may be the same material, it may not be. As this part, I have a feeling it's not the same, this seems a little bit more rubbery to me. I have this, inside it I have a liquid, and I have that, whatever this kind of foamy thing is. So I have a felt. So I have 4 different things in here all together, because as engineers, we design composite bodies, right? So when we're dealing with this, those 4 elements have different masses, they have different areas, they have different volumes, and they have different weights. So probably for a composite problem, these 2 will probably come out to be the same. In physics and math, when you did it, you looked at one weird shaped body, one body, homogeneous, and if you did the calculation for that using integration, you would have found they're all in the same spot. But in engineering, I know you know how to do the integration, you did it before on finding composites of one body, but now, finding the centroid, the center mass, or gravity of one body, but as engineers, we need to find it of a composite body. Hang on.
The
Chris
mass
Paul.
and weight will always be the same, right?
The mass and weight are different values
Yeah,
because,
have to be the same.
but they should have the same point.
Yeah.
Yeah. But then, now it's getting into a physics question that I don't know if I could answer. Then there's something like if you go on the moon, it's something different, and I'm not going there, I don't know it. Paul?
So, you said composite, so steel reinforced concrete. If you have 10,000 pounds of reinforcing steel and then you have concrete, would you consider that a homogeneous structure?
I wouldn't.
You wouldn't.
I would not.
So you would have to calculate the center mass of the steel.
And the center of mass of the concrete and find out where the center of mass of that concrete slab is, which has the reinforced bar in it.
So that's a regular.
Yeah, so Paul's talking about when you have a slab of concrete, you have reinforcement rebar inside, right? And they have different, the steel, the bar is made out of steel, the concrete's made out of rock and cement. And in the end, it is a composite body because there is concrete and then there's also steel, and they both have different masses, different weights. They have different geometry, and there would be a composite body. If you wanted to find the centroid of a concrete slab that has steel in it, you would have to use both of those. So to simplify it, that's all we're doing, is we look at a problem and we have to figure out, is it centroid? Is it center of gravity? Is it center of mass? What are they talking about? And the way we know is, did they give us the mass? Did they give us the weight? Did they give us the geometry? Then, for centroids, is it 2D or 3D? If it's 2D, we know we're dealing with area. 3D, we're dealing with volume. And this is the only equations we're using. If it's center of gravity, we're summing up the weights times the distances and dividing it by the weights. If it's center of mass, we're summing up the masses and times them by the distances. and then divided by the mass. Areas and volume, it's the same equation. Now, this is something that's not, that's not so important, but it's good to just, to realize this because you might see this. Santiago already told us that this is what? Sum of the moments, right? Right, sum of the moments, right? You said if you multiply the forces times the distances, we're talking about sum of the moments. Believe it or not, this is called sum of the moments. This is called sum of the moments. This is called sum of the moments. These are all called the first moments. First moment of, first moment of mass. First moment of area. First moment of volume. Did everybody get that? So we would all agree that that is indeed a moment. You're summing up the forces times the distance, it's a moment. It's the moment of weight. This is the moment of what? Mass. This is the moment of area. And this is the moment of volume. I didn't hear everybody. Moment of? Mass. Moment of? Moment of? Moment of? Weight. And this, what did I say it was? The first moment, right? This is the first moment. First moment. First moment. First moment. What was this of? Of weight. Hang on a second. First moment of mass. First moment of area. First moment of volume. So I guess you do have to write this down. I just have all the math there for you. Calculation. So if you want to write this down. I'll get your question in a minute. Okay. So David just asked about, what about units? So what is this one? The first moment of weight. What's the units of moment? Foot pounds. What's another example? Newton, meter. Are these the units of moments that we've already known? Chris, you with us?
Yeah.
These are the moments that we know, right? Already? Okay. Well, what's the unit here? Give me an example. Kilogram meter. Give me another example. You guys even know what the foot slug? How about this? What's the unit here? This is a weird one. Try it again. It's area. Area times distance. Foot cubed. Meter cubed. How about this one? Foot to the fourth. Meter to the fourth. Personally, if I had derived all this and discovered this, I wouldn't call them moments because I think it's confusing. But they are called moments and we have to accept that. What did you learn in physics and maybe in math that you're going to learn again here? A moment of inertia. When you take, instead of the first moment, the second moment of mass is called what? Moment of inertia. And the second moment of area is also referred to as moment of inertia. Even though it's not really moment of inertia has to do with distribution of mass. We'll look at some examples of when you actually would use that in engineering. The moment of inertia has to do with the distribution of mass in composite bodies. This is the distribution of, what do you think? Area. What do you think the units are of this? The units here are kilogram meter. This was the first moment, and you noticed in all the moments, you multiply by a distance, right? Moment of mass, multiply by distance. Moment of area, multiply by distance. Moment of volume, multiply by distance. So these are all the first moments. You're trying to